This trig identity that we're going to do is possibly a little harder, but it's different. And we pick out something, I've picked this one because it introduces the concept of, quote, introducing something extra to it. We're going to actually multiply to make the denominator right. We're going to multiply by the conjugate. Very much like what you would do if you were trying to rationalize a denominator that had a radical in it. Anyway, this is the identity. Secant of x over the secant of x minus the tangent of x is equal to the secant of x times the secant of x plus the tangent of x. You may be looking at this and saying, why would I want to show this? Well, to practice your algebraic skills, if nothing else. Would you ever need this in real life? I have to admit that's a bit of a stretch, but let's have fun with it. Because really, when you get good with trig identities and you get to where nothing is a challenge to you anymore, it's because it's become very fun. So here we go. I have now in previous ones I have reduced to cosines and sines and things like that. But if I start doing that here, I can guarantee you it's going to get kind of messy. I want to show you a nice way to do this. I'm going to keep everything in terms of secant and tangent, but I'm going to multiply this guy by something else that's equal to 1. I don't have to do it on both sides. I'm just doing it times on this side here. Because remember, I do not, with an identity, multiply the equation through. I want to show that this is equal. I don't show it that it's equal by multiplying through and canceling stuff. That doesn't do it. So I'm going to multiply this by what's called the conjugate, which is the secant of x plus the tangent of x. Minus sign here, plus sign here, everything else the same. I'm going to get secant squared minus tangent squared on the bottom. But if, of course, if I do that on the bottom, I have to do it on the top, and I get secant of x plus tangent of x times the secant of x, which is what I'm going to get here. So really my problem now comes to be that I need to show that this times this is equal to 1. So I'm going to do that. I'll keep the top like it is. I'm going to keep the top as secant of x times secant of x plus tangent of x. Remember, all I'm doing is working with this left side here. Secant of x times secant of x plus tangent of x. On the bottom, I have secant squared x minus tangent squared of x. Now I'm going to write these in terms of sines and cosines. I'm not going to do that on the top. That's just going to clutter things up. But I'm going to write now, this is going to be secant of x plus tangent of x, that's my numerator, divided by 1 over the cosine squared of x minus the sine squared of x over the cosine squared of x. Right there, I'm relying on my basic trig identities that says that the tangent is equal to the sine over the cosine. The secant is equal to 1 over the cosine. What's nice is I have the same denominator for both of these fractions. So I'm going to write this now as one fraction. So I have secant of x times secant of x plus tangent of x. Numerator hasn't changed. And on the bottom, I now have 1 minus the sine squared of x over the cosine squared of x. But that, let's just now rewrite that here. Remember that sine squared, this is in your toolbox. You're reaching for it right now. It's already warm from the last time you reached for it because you reached for it so much. Sine squared plus cos squared is equal to 1. So we can rewrite this as 1 minus the sine squared of x is equal to the cosine squared of x. And that's what I'm going to do here. I have, as usual, secant of x times secant of x plus tangent of x. And on the bottom, I now have 1 minus the sine squared, which is the cosine squared of x, divided by the cosine squared of x. And this whole thing here is 1. Therefore, I have shown that this is equal to this, because that's what I end up with. Let's just finally write that. That's equal to the secant of x times the secant of x plus the tangent of x. And I'm done. Remember, don't put a box around anything. How we start, and we show our work, and we work our way down, and we get to the right-hand side, that is the answer.